Okay, the third part of doing emissions measurements is the final measurement, or just the measure. Remember, we have scan, search, and measure. So the first thing you typically want to do when configuring the final measurement is to make sure you're using the detectors that you want to use. Now recall, we've already seen how to set the detectors for the scan. That's under the trace function, under detectors. And you've also seen that when we go to set up the meters, there's a place to set up the detector for each meter as well. The third place where you set up detectors is under Mesh Setup for the measurement. So the detectors that are used for the final measurement do not necessarily have to be the same detectors that you're showing on the meters, and they certainly don't have to be the same detectors you used for the pre-scan. You have complete control over the final measurement detectors. Now these are the detectors that are at the head of these three columns. So it is true that right now we've got the same detectors for the final measurement as we do for the meters, but we can change that. Let's say we want detector 2, which is the one in the second column, to be the RMS average. And of course, we're given this prompt that if you change the column, you're going to have to throw away all the data in the column. And remember, you just hit the enter key to respond to a prompt like this with a OK, and you hit the cancel key if you want to respond with a cancel. But since we're using remote desktop here, we can just click on OK with using the mouse. And so now we have the RMS average detector heading up the second column. And we can actually go to the third column and set the detector to be the quasi-peak here. And again, we have to respond with an affirmative. Now you notice that it picked 1 second for the dwell time for the quasi-peak detector and the RMS average detector, and it picked 200 milliseconds for the dwell time for the peak detector. So it tries to pick a dwell time that's most likely going to be around the dwell time you want to use when you're using these different detectors. Each detector you can set a different dwell time for each detector for the final measurement. Okay, so now notice that our column headers don't match up to our meter detectors. So again, you have three different places where you can set up the detectors for each of the three regions of the screen. Now there's some mesh setup parameters that apply only to uh, the final measurement, and one of them is auto ranging. So when you do the final measurement, you can decide to have the box auto range or not. And what that means is, as it goes from signal to signal, it will set the attenuation and the preamp so that it optimizes the dynamic range of the analyzer for measuring each particular signal. And this is very important because if you're dealing with strong signals, you want to maybe lower the gain or put in some attenuation. If you're dealing with weak signals, you want to be as wide open as possible. So you can actually optimize the dynamic range on a signal by signal basis. You can also decide whether or not turning the preamp on or off is an option. It's part of the algorithm. And you can also say that I don't want ever to have less attenuation than 10 dB. So you can configure the auto range to some extent. And if you turn it on, then every time it does a signal in the signal list, it's going to use the auto ranging. Now, when you go to make the measurement, if you look at the scan sequence, you are basically going to select the measure function or the search and measure function or the scan, search, and measure. Each of those contain a measurement function. When you do the measure, it's actually called re-measure because you might be doing a re-measurement. Uh, After you've selected it, you can click on the key again and you can decide to use the current signal. You can, so that would just be a final measurement of the current signal, or you can measure all of the signals in the signal list, or you can measure just the signals that you have marked. And remember, we saw how to mark signals before using either the mouse or the select keys as you go through the signal list. So I'm going to configure it to measure all. Okay, so if I now hit restart, it will go through the signal list using the detectors that I selected and make a final measurement at each one of these points. Now, before I do that, I want to show you that there is another way to do a spot measurement uh, of a single frequency using the same parameters that you've already configured for the final measurement, and that is to do a measure at marker. So if you have a marker, and I just clicked on peak search to get a marker into my display, I can go to marker function and select measure at marker, and what it will do is it will actually go to the signal at the marker and it'll make a final measurement just at that point using the detectors that I selected. And I actually now have the option of putting that measurement into the signal list by going to marker 2 and selecting measure at marker result to list. So if I do that, then it will actually put that result in at the point where the current signal was. So it's in the list, and you can see that it's also showing me the delta to each limit line. And notice it's configured to right now. It's using limit line 1 for all of the deltas, but I can actually go and configure each detector to use a different limit line, because sometimes I might want to have one limit for the peak detector and another limit for the quasi-peak detector. Now the way I do that is to go back to mesh setup, and under detectors I can pick which limit I want to use for each delta. So I can change this the first column, and I say I want this column to be relative to limit line 2 and leave these other two relative to limit line 1. So you have complete control over what's displaying in those limit line columns. Notice also the scroll bar here. There is actually more information in the signal list that you can't normally see because it sits off to the right. For each signal, the res bandwidth that was used to measure the signal is displayed, and the time at which the measurement was taken is displayed. And if you don't have a mouse, again, you can go into mesh setup, signal list, navigate, and you can scroll left and scroll right using the soft keys. Okay, so when we do a final measurement, we're actually using the same functionality that we used to do the measure at marker, only we're doing it at each frequency in the signal list, and we don't need a marker to do that. So let's turn off the measure at marker window, and let's go ahead and execute a remeasure all function. Now you can tell what scan mode you're in by looking at the measurement bar here. So remember, we're in the measure all sequence. If I change it to scan, then it shows the scan up here, and there's other values displayed up here like the trigger type. If you're doing a scan that involves scanning more than once, it'll show you which scan you're using. There's also meters annotation up here that show the meter attenuation, whether the meters are in single or continuous. And of course, it reads out the EMI standard that's being used at any given time. So the measurement bar is kind of a summary of measurement related information. Okay, now before I start the final measurement, I actually want to zoom out so that I'm looking at the full spectrum, and this will let me watch as I go from signal to signal and give me some sense of the progress of the final measurement. Now the measure window that you see here, the one that was used for measure at marker, is also used for the final measurement, just the way the same detectors are used for the final measurement. So now I can begin the final measurement. I'm going to go select remeasure all again and restart the measurement. So you can see now, you see the entire spectrum, and you see the each signal as it's being measured appears with a little green X, meaning it's the selected signal. And so it's going through and it's making the measurement signal by signal. And you can see that limit line delta column is being populated for limit line 1, and the one that we turned on for limit line 2 is not being populated because we don't have limit line 2 turned on. So it's going to go through each of the 80 some odd signals in the signal list and do a final measurement for each signal. And because this is the part of the measurement where you actually have to dwell for a longer dwell time with the weighted detectors, like RMS average and quasi-peak, this is a more time-consuming part of the measurement than the scan or the search. That's why you want to get your signal list to contain exactly the signals and only the signals that are of interest to you before you do the final measurement, because the final measurement is going to occupy most of your time when you're doing one of these qualifications. Okay, well, we're almost all the way through the signal list now, and you can see that it's been going through signal by signal and filling the data in. And so when it's complete, then it will stop, and we'll actually be able to export that signal list to a CSV file, which will allow us to use it to generate data for a report. And you can also load the signal list back in, which is very useful if, for example, you're trying to establish a baseline for your facility. You can save the ambient signal list and then load it in every time before you start the test, because when you do a search with an existing signal list loaded, it always adds the new signals that it finds to the signal list rather than overwriting the existing signal list. So that's basically the way the final measurement works. And again, you can save every part of this. You can save a state file, which will essentially act as a setup file, contains the limits, the amp core. It contains the scan table and the complete state of the analyzer. It also you can also save the signal list, and you can individually export items like traces and the limits and amp core tables. So you can very easily save all of your data, and of course the screenshots we talked about earlier. So those are the three parts of emissions testing: scanning, searching, and measuring. And now we're going to move on and talk about the strip chart measurement, which is the other measurement in the EMI receiver. And then we're going to talk about some enhanced display modes in the spectrum analyzer.